In this video, we are going to go over some definitions that we have already learned and talked about. Let's start off with linear functions. Linear functions make straight lines. They have a degree of 1. Remember, if you think back, a degree means that your highest exponent. So like quadratic, our highest degree was 2, making it a quadratic. With linear functions, the highest degree is 1, making it a line. We typically use slope-intercept form, which is y equals mx plus b. You could also see it in standard form, ax plus by equals c, or point slope form, y minus y1 equals m times x minus x1. With linear functions, you always have one x-intercept and one y-intercept. And then your rate of change. Your rate of change is the same thing as the slope. With linear functions, your rate of change is always constant. This is unique to lines. So this is unique to linear equations. You can pick any 2 points that fall on the line and you will get the same slope every time. Next, we learned about exponential functions. For exponential functions, you will have exponential growth if b is greater than 1, and you will have exponential decay if b is in between 0 and 1. So here, the formula that we used to find the transformations was y equals a times b to the x minus h power plus k. Remember, a, h, and k are your transformations. With exponential growth functions, or exponential functions in general, your exponent is a variable. And exponential functions have an asymptote. This is the line that the curve approaches more and more closely, and it always is of the form y is equal to k. For exponential functions, you could have 0 or 1 x-intercept, and you will have 1 y-intercept. When we talk about an exponential function's rate of change, it is variable, meaning that it's always changing. So you could check the rate of change between 2 points, and then you could check it for another 2 points, and you will not get the same slope. And that's what this means by variable. It varies. And then we learned about quadratic functions. Quadratic functions make parabolas. They have a degree of 2. And we learned 3 different forms when it came to quadratic functions. We learned standard form, y equals ax squared plus bx plus c. We learned about vertex form, y equals a times x minus h squared plus k. And we learned about factored form, y equals a times x minus p times x minus q. For your intercepts, you could have 0, 1, or 2 x-intercepts. And you will always have 1 y-intercept. And your rate of change for quadratic functions is also variable. It will change depending on what 2 points you pick. So we've talked a lot about rate of change. So let's go back to that for a second. Rate of change is the same thing as your slope. So we've used the letter M to represent slope, and we have found slope a couple different ways. Using rise over run, using y2 minus y1 over x2 minus x1, or by doing the change in y over the change in x. Your domain are your x values from least to greatest. If you are looking at a graph, it is from left to right. Your range are your y values from least to greatest. If you are looking at a graph, it's from the bottom to the top. Your x-intercept is where your graph crosses your x-axis. Your y-intercept is where the graph crosses the y-axis. And your asymptote, if we're talking about linear, exponential, and quadratic functions, this only occurs for exponential functions. It's the line that the graph approaches more and more closely. And it's always of the form y is equal to k. So those are some of the definitions that we have talked about and learned about throughout our units this school year. If you go to the next page, we have kind of like a graphic organizer here. So here we have our linear equations. We have our arithmetic sequence equations, which are the same as your linear equations. Remember, this is when you had your common difference and a sub 1 was your starting value. And then, actually, you need to fix something on this. I just noticed. This right here should be a sub 1. And then we have some examples of linear equations and an example of a linear graph. In the middle column, here we have exponential equations. And here are some formulas from exponential equations. We also have the formulas for geometric sequences, which are also exponential, most of them. And here are some examples of exponential equations and an example of an exponential graph. And then last but not least, over on the right-hand side, we have our quadratic equations, some examples of quadratics, and a graph of a quadratic equation. Any formulas that are in black here are not given to you on the formula sheet that you'll be able to use on the milestone. So if you're looking at these top places up here, anything in black is not listed on the formula sheet for the milestone, but everything else that is in a color is.